So 4.0 definitions, you're gonna learn some key terms for statistics, and you're gonna use that to apply to the first part of your statistics project. So a few terms that you kind of need to know. This is the first page on the packet if you do have it. Consensus. It is a count or measure of the entire population. Okay, think about it. They were pushing that 2020 census just last year because they want to essentially get the entire US population. Okay, every single person who lives in this country. That's a census, a count or a measure of the entire population.
How accurate is that?
I don't know percentage-wise the accuracy of the census, but they try their best to get everybody. Like they go door to door even.
What about like homeless people? So.
They try to get them too. That like some of the people who go like door to door, like they'll try to get them as well. Now, because like you said, you know, the accuracy of getting the entire population is probably not possible. Even like when Ms. Dunstan sends out a survey to the entire school population, they don't get all 1,500 students, right? And so that's where sampling will come into play. Sampling is a count or measure of part of the population, okay? So when you can't get the entire population, then you pull a sample, all right? Now there's different types of ways that you can pull the sample, and we'll talk about that on the next slide. When you pull a sample, there's a possibility of a sampling error. Sampling error is the difference between the results of the sample and those of the actual total population. Okay, so it's the difference between what the sample results say versus what the entire population says, and that's known as your sampling error. Error can happen when you're doing things with statistics because of a lot of different variables. And you want to make sure that when you're doing different projects or, you know, when you're working on different examples that deal with statistics, you want to kind of take note of like, okay, well, this probably couldn't be accurate because of, you know, people weren't here at school to collect the data, or there was a bias or something with how they collect the data. You know, you kind of always want to keep those things in mind when it comes to collecting data. These are your different types of sampling techniques. Simple random sampling is probably the most common way that data is collected. It basically means that every person has, or every element, every member has the same chance of being selected, right? So, prime example, when I am calling on you guys in the class, everybody has a possibility of being called, okay? So that is basically a 9% chance of being called because there's no rhyme or reason why I call on you who I call on, okay? So that's an example of simple random sampling. Everybody has an equal chance of being selected, equal probability of being selected.
The teacher calling on you, being what we write.
Yeah, like so basically like pick up on it as I go through it. All right. Now systematic sampling, okay? There's a key word in there, okay? There's a system behind how you are going to select your like the people you interview, right? You're selecting at a random interval. So prime example, I wanted to collect data on the age of people going to the mall, right? So I stand at the door and I say, okay, I'm going to take data from every third person that comes through this store, right? So the first one comes in, I don't ask them. Second person comes in, I don't ask them. But that third person, I ask them. Then I repeat it again. The next person after that, the sixth person. Okay, not the 7th, not the 8th, but the 9th. Okay, so you basically select them at the same interval. Okay, and it's a random interval. So you can say the third person, the 10th person, the 12th person. You decide at which interval you're going to select to collect your data, and then that is how you do a systematic sampling. Cool. Convenience sampling. It's called convenience for a reason. It's easier to select the data because it's convenient, okay? you, Danielle, you decide to ask Dorealis, you know, what is her height because she's near you or she's in the same class as you. Or you may ask her because, hey, I need to collect data and you have to collect data as well. So you're more likely to respond because you know that I'm going to respond for you because we both got to do it. You know, basically more likely to respond or easier to get. Okay. Like you may ask your friends for their opinion because they're your friends. They're going to respond to you, but you're not going to ask, you know, a person that you see in the plaza because you might not know them unless you're just that outgoing, you know? Me. Now, stratified and quota sampling, they have the same type of definition, but as you can see, stratified is random and quota is biased. I'll talk about that in just a second. I want to make sure everybody understands this definition. A stratified or a quota sampling is when you take a group and it's divided into subgroups and each group is represented fairly. Okay, this is what I mean by that. All right, let's take our school and let's say roughly we got 1,500 kids. And Ms. Dunson is creating a new committee. Yes. I'm making this up. This is a part of stratified and quota. This is the example that I'm providing for you. Yeah. All right. So we got 1,500 students. Ms. Dunson wants to create a new committee that has 50 students in it. Okay. But she wants to make sure that all grade levels are represented in this committee. Okay. So the entire school population, she's creating this new committee, this subgroup that is going to have every possible grade level represented, right? So let's say, and I'm just making up these numbers, there's 400 freshmen, okay? There's 300 sophomores. There's 400 juniors, let's say 500 juniors. And then there's 300 seniors, right? That's how many students there are in Lake Wales. So if she wants to try to make sure that every group is fairly represented based off of their size of each of their subgroups, then what she will want to do is take 400 divided by 1,500 and then multiply that by 50. Somebody do that right now. I'm going to ask you for the other ones as well. So pull out your calculator. What is 400 divided by 1,500 times 50? It's 13 point what? So it's 13.33. So she's going to take about 14 students, right? Let's do the same thing for the sophomores and the juniors and the seniors to figure this out.
Juniors is 17.
Juniors is 17. Sophomores is what?
10.
10. And then seniors will be what?
10.
It'll be 10. Help me out. What were the decimals prior to, like, what was the numbers of the sophomores before you got it to 10?
10.
It was 10 on the dot?
Mhm.
Okay. What about the juniors?
16.6.
16.6? Okay. Oh, 16.6?
Repeating.
Okay. So then we'll knock this one down to 13. So roughly she would take about 13 freshmen, 10 sophomores, 17 juniors, and 10 seniors for a total of this 50-person committee where each grade level is represented based off of the number of students that are in those respective classes. It would make sense that the juniors would have more representation because they make up more students out of each of the individual classes. Yes, sophomores and seniors would have the same amount because they have the same amount of students. That is what a stratified / quota sampling is. The difference between the two is that when she decides to select these 13 freshmen, these 10 sophomores, 17 juniors, and 10 seniors, stratified means she just randomly selects 13 freshmen. She randomly selects those 17 juniors, okay? But quota would be she selects 13 IB freshmen or 10 IB seniors or 17 IB juniors. It's a biased sample because she's selecting from a particular type of group out of the entire population of freshmen, sophomores, juniors, and seniors. So what we're going to do now is look at a couple examples to make sure you guys understand the differences between the different types of sampling techniques, and then we'll talk about what you guys are doing today. So you don't have to write this down. If you want to get this later, you can. You can watch the video because I am recording. It says an annual dog show averages 3,540 visitors. The catering manager is conducting a survey to investigate the proportion of visitors who will spend more than 20 euros, francs, on food and drinks at the show. He decides to survey the first 40 people through the gate. What type of sampling technique is that?
Systematic. Well, no, I guess, would it be simple randomly? Wait, does systematic, does it have to be like every third or every 10?
Yep, systematic has to be every particular interval.
And I would say, always first 30.
It would be convenience. And the reason why it would be convenience is what?
Just the first 40 people, so that's the easiest.
Yeah, that's the easiest thing to do, right? You got 3,540 people that are going to be coming in. He's like, oh my goodness, before they get too deep in here, let me just get the first 40 people that walk through the gate.
But if he took everyone, sat them down and was like, it'd be simple.
It'll be simple. Now, if he stood at the door and he said, okay, I'm going to collect every 10th person, then that would be systematic. What about the next one? This one's for you guys online. A library manager is interested in the number of people using the library each day. She decides to perform a count every 20th day for 1 year, starting next Monday.
Would it be systematic sampling?
It would be systematic sampling, yes, because they're taking that count every 20th day for 1 year. Okay. Let's look at this one. Mona wants to gauge the opinions of her peers on the design of the school's yearbook. She uses her own homeroom class as her sample. This one would be convenience, because she could go out and she could ask everybody at the school, but she decides to use her homeroom, right? People that she sees every day, they become comfortable with each other. They are convenient. They are convenient. Now, I'll say that for the next question. Look at this one. Lucian is a school counselor. He wants to raise awareness of student cyberbullying with the students' parents. Lucian therefore wants to find out whether students at the school have discussed the issue with their parents. Explain why it might not be practical for Lucian to use a simple random sample or a systematic sample.
Well, the simple would be everyone, and like not everyone's doing cyberbullying, right?
Exactly. So, a simple random sample would be just any random, like any person, but not everyone's being cyberbullied. Very good. Why wouldn't systematic? What's another reason why systematic or simple not work? Because there's more than just one correct answer here. This is where like that whole explanation about, you know, why a particular process might not be the best thing to do. Will be another reason why somebody would, why simple, random, or systematic might not work to try to collect information about student cyberbullying.
Students might not all have like parents that have just parents.
That's true. Some students may be in a particular situation where they don't have parents.
Or because cyberbullying doesn't just happen on a specific day, so it's not like you can do it every third day.
That's true, right? It doesn't happen every third day.
Every third person you don't know who's.
Yeah.
Right. Or better yet,
It could be the cyberbullier.
exactly. The person you may ask may be the cyberbullier. or maybe the person that you asked might not want to respond. Okay, so doing it in a simple random sample or systematic sample might not be in your best interest because of these different types of variables that I was talking about earlier.
So which one should you do?
So here we go. Lucian wants to make sure that each gender is appropriately represented in his sample. So should he use stratified sample or quota sampling?
Well,
I would say quota.
because you have to have specific, you're specifically the side of bullied, not bullier. So like that just would make more sense because you'd be like, okay, only fill this out if you've been cyberbullied.
Well, it's also like each gender, so you can't randomly select people because you're not gonna get, like you could randomly select 13 boys
Mm-hmm.
and not 13 girls.
Right.
So like you're gonna select, so it's gonna be quota, so you can pick them.
Exactly. And that's why either of these two methods would be the way to go for something like this. Okay. Quota, for one, if you want to make sure that both genders are represented, you are going to have some bias, because based off of whoever you do collect, you're trying to collect from a particular group of students that are being cyberbullied. So then from there, once you actually have that group, then you'll need to split them based off of their gender. Very good. Questions on this one?
I have a question about something else.
Okay.
Are you doing an attendance question for now? These are fun.
All right. The 200 students in years 11 and 12 at a high school were asked whether or not they had ever smoked a cigarette. The replies received were as follows. So N clearly meaning no and Y clearly meaning yes. They're grouped in groups of 5, and this represents 200 students. Okay. Why is this considered to be a census?
Because it's the entire population.
It's the entire population of years 11 and 12 at this particular school. So they were able to get everybody at this particular school. This is the entire, every student that's in grade 11, grade 12. Now, look at these examples here. I through 1 through 6, all right? You got sampling the first 5 replies. Like basically, this is like a part of like question B, but I didn't want question B, I wanted like the last question. So these were a few different options they could have had to pull a sample from this entire census. Sampling the first 5 replies, sampling the first 10 replies, sampling every second reply, sampling the 4th member of every group of 5, randomly selecting 30 numbers from 1 to 200 and choosing the response corresponding to that number, sampling 20% of year 11 students and 20% of year 12 students. These are all the different ways that they could have collected a sample from these 200 students. Are any of these examples of simple random sampling, systematic sampling, stratified sampling, or quota sampling? Don't answer right away. Think about it. Any one of these, 1 through 6, were any of these examples system random sampling, systematic, stratified, or quota? Online. Wasting tape.
Are y'all sleepy?
Better not, I'm gonna kick you out in a second.
I think 3 and 4 are both systematic.
You think 3 and 4 are both systematic? You would be correct. And why would you say systematic?
Collected at random intervals.
Because they're at random intervals, exactly. Very good. 3 and 4 are both examples of systematic. In the classroom, do you see any other of these 4 within 1, 2, or 5 and 6?
The last one, 20%.
Hmm?
With the last one, like it being 20%, because that's like.
Wait, wouldn't 6 be quota though? Because it says sampling 20% of year 11 students
And then
and 20% of year 12 students.
Mhm. Now, this would be an example of either stratified or quota,
Okay.
because it doesn't specify if it's 20%
For-
boys or 20% honor students. It just says any 20%, but it's still collecting it like a subgroup of each grade level. So this would be stratified, and then depending on the situation, it could be quota, but it falls underneath those two.
Would the first two be convenient?
The first one would actually be convenience because you're just selecting the first 5 replies.
What about the second one? Wouldn't it, cause first 10?
And so the first 2 would actually be, they both would be convenience. All right, so online, what would 5 be? Randomly selecting 30 numbers 1 through 200 and choosing the response corresponding to that number.
Would it be simple random sampling?
It would be. Keyword, that randomly. Okay? It's like you're putting 200 numbers in a box and you're just pulling out 30 pieces of paper and you're selecting those individuals to respond. And that's good. Some of the things that kind of came up as we were talking are things that you guys need to consider when you yourself collect data, which is what you guys are gonna be doing. But any questions on our sampling techniques or any of the basic definitions?